Good afternoon. On previous term, my last definition was universal set. Uh, if all the set under consideration is a subset of larger set, then this larger set is called the universal set. And universal set is not fixed; it varies from situation to situation. Now I come to interval as a subset of R. Interval as a subset of R. Number one, closed interval. The set defined as all x such that x belongs to R is less than or equal to x is less than or equal to b. It is also denoted by is called closed interval. This set consists of all real values between a and b, including a and b. Now, second, open interval. The set all x says that x belongs to R, a is less than x is less than b. It is also denoted by open interval AB is called open interval. It includes all the real values between a and b, but not a and b, means excluding a and b. Third, semi-open. Interval. The set all x such that x belongs to R, a is less than x is less than or equal to b. It is denoted by is called semi-open interval. In this consists of all real values between a and b, including b and excluding a. Fourth, semi-closed interval. The set all x such that x belongs to R, a is less than or equal to x is less than b. It is denoted by is called semi-closed interval. It includes all the real values between a and b, including a, excluding b. Now you can denote it on the number line first. This is a real line, minus infinity to plus infinity. This is A, this is B. A and B both included, so I make it dark, and then this is also dark. This is the closed interval A. When you represent second on the number line, make a real line. This is from minus infinity to plus infinity. A and B, put them on this line. A and B are not included, so you leave them and make shaded line between A and B. This is the open interval AB, and third one semi-open. For semi-open, you draw a real line. It is minus infinity to plus infinity. Put A and B on it. Since B is included and A is not included, so dark this part. This is semi-open AB. Now last one is semi-closed. For semi-closed, make a real line, minus infinity to infinity, mark A and B. A is included, B is excluding. This is semi-closed. In semi-closed, left side is included. In semi-open, semi-closed, left side included, and in semi-open, left side excluded. Remember that. Now question. I am doing some question here. Consider the following set. Consider the following set. Phi A C insert the correct symbol. My question is, your set phi A, B, C are defined. In this question you have to insert the correct symbol. Subset of or is not subset of between each pair of set. First, B, second, third, A, C, fourth, B, C. Now this question is based on is subset of. This question is based on is subset of or is not subset of. So first you remember the definition of subset. A set A is said to be a subset of B if every element of A is element of B. Then it is a subset. And you have seen in the note, empty set is a subset of every set. And the set itself is also a subset of that set. So these are two properties of subsets. First thing, in first question, your phi is empty set and B is 1, 2, 3, 4. Since empty set is a subset of every set, then you put the symbol here is subset of. And next one, you come to this part, A and B. In set A, 2 belongs to A, 2 belongs to B. 5 belongs to A, 5 does not belong to B. So every element of A is not the member of B, because 5 is not the member of B, but 5 is member of A. So here A is not subset of B. Now A and C, 2 belongs to A, 2 belongs to C. 5 belongs to A, 5 belongs to C. In this way, every element of set A is a member of C, therefore A is subset of C. Now, fourth part. What about B and C? 1 belongs to B, 1 belongs to C. 2 belongs to B, 2 belongs to C. 3 belongs to B, 3 belongs to C. 4 belongs to B, 4 belongs to C. In this way, every element of B is the member of C, therefore B is subset of C. So in this way, you tackle all such type of question. Now come to second question. In second question, I am writing some statement in connection with sets, and we have to observe that, we have to find out the answer, that whether they are true or false. So, which of the following are true? Next question. Which of the following are true? Number 1. If then A is subset of B, A is subset of B. Second, if A equal to 2, 3, 9, B equal to 3 to 9, then A is subset of B, A is subset of B. Third, if A equal to 1, 2, 3, 6, B equal to 2, 3, 6, then B is not subset of A, B is not subset of A. Fourth, if A equal to 1, 5, B equal to 1, 3, 4, 6, 9, one, 3, 4, 6, 9, then A is subset of B, A is subset. Now you have to follow the definition of subsets again, and you have to find out for the given two sets A and B whether these statements are true or false. Which of the following are true? You have to find out that. Here you see each element of A is an element of B, therefore A is subset of B. So this is what you can say about first part. This is true. Because this follows the definition of subsets. So therefore this statement is true. Now you come to second part. Element of A is 2, 3, 9, 3 to 9. Elements are identical. Elements are identical, but you have given that A is subset of B, A is subset of B. Your elements of set A and B are identical, but their order are made different. That doesn't matter. But elements of A and B are identical. Elements are same. So this will follow the definition of equal sets. So in this case, you find A and B are equal, but you have given that A is subset of B and A is subset of B. So in this way, you can say this statement is false, because the given sets follows the definition of equal sets, but we have given as a result they are subsets. Therefore, this statement is false. Third, if A is given as like this and B equal to 2, 3, 6, you see that all the element of B are the member of A. So your B is subset of A, but here you have given that B is not subset of A. So what you can say about this? This is also false. If A equal to 1, 5, B equal to this, 1 belongs to A, 1 belongs to A, 5 belongs to A, 5 does not belong to A, but they are given, they are subsets. A is not subset of B, but they are given, A is subset of B. So this is also false. So out of these four statements, first statement is true and remaining are false. Now comes to next question. Third, let A equal to 1, 2, 3, 4, B equal to 1, 2, 3, C equal to 2, 4. Find all sets X. Your question is, find all sets X. Satisfying find all sets X satisfying each pair of condition. Each pair of condition number 1. X is subset of B and X is not subset of C. This is the first part. Now second part. X is subset of B and X is subset of B. X is not equal to B. And X is not subset of C. This is the second part. Now third, X is subset of A, X is subset of B, X is subset of B, and X is subset of C. For a given set ABC, find all set X satisfying each pair of conditions. The conditions is given in the following question. The set X, you have to find out all the set X, this satisfies these conditions. That is the question. So you can write only when you write the power set of each set. When you write the power set of each set. So you write power set of set A, power set of set B, and power set of set C. You write power set. How do you write the power set? Power set of any set is a collection of all the subsets of the given set. It is a collection of all the subsets, power set of A. So in this case, your power set of A is null set, and 1, 2, 3, 4. This is the power set of A. Now you write power set of B. Power set of B, that is null set. Now power set of C. Null set. Two, 4, and 2, 4. You have written the power set of, by following the definition of power set of any set, you have written the power set of each set. Power set of A, power set of B, power set of C. Your first question was find all set X which satisfy the condition X is subset of B and X is not subset of C. X means subsets. X is subset of B and X is not subset of C. In this case, you have to find all X. Now you see your power set of B and power set of C. Phi is here, phi is here. Phi is subset of B and phi is subset of C. Therefore, X is not C. X is not phi. Because phi is element in both power set of B and power set of C. Therefore, phi is not taken as X because your condition is X is subset of B, X is not subset of C. This set phi is present in both the sets. They are as a subset of B and C both. Therefore, this phi will not taken as X. Now, next, this set, if you take this set 1, singleton set 1, this set is a subset of B, but this set is not a subset of C. So for x, you take singleton set 1. This is your first set x. Now to this set, if you take x is set to this set, so this is a subset of B, but this is also a subset of C. You are given that x is not subset of C. So in this case, this will not taken as x. Now 3 is subset of B. This set containing element 3 is subset of B, but this is not here. So x is taken as set, singleton set 3. Now 1, 2, the set containing element 1, 2 is subset of B, but this is not subset of C. So 1, 2 is taken as x. 1, 3 is subset of B, but this is not subset of C. So x is taken as. I hope that you understood this concept. 2, 3 is subset of B, but 2, 3 is not subset of C. So in this way, this consists of 2, 3 also. Now, what about 1, 2, 3? 1, 2, 3. 1, 2, 3 is subset of B, but this is not subset of C. So this x is also taken as 1, 2, 3. So all the set x satisfying this condition, x is subset of B and x is not subset of C, is x equals to singleton set 1, singleton set 3, set containing 1, 2, set containing element 1, 3, set containing element 2, 3 and set containing element 1, 2, 3. All sets are taken as x because this is subset of B, but they are not subset of C. Now come to second part. X is subset of B, but x is not equal to B. These two conditions are there. There is only one thing is extra, that is x is not equal to B. In this case, your x equal to B. You delete this element only for this part. So the moment your conditions are changing, you change your solution. So if x is not equal to B, so you cannot take this set as x. So your x is taken as this 1, 2, 1, 3, 2, 3. That's all for this part. X is subset of A. X is subset of B. Those elements which are subset of A, B, C, all. Phi is here, phi is here, phi is here. So x is taken as null set. This is the first. Next one. 1 is subset of A, 1 is subset of A, 1 is not subset of C. So 1 is not there. 2 singleton set 2 is subset of A, 2 is subset of B and this. So singleton set 2. Next one, singleton set 3 in A, singleton B, but this is not in C, so you cannot take that. Singleton set 4 there, singleton set 4 is not here, so you cannot take that also. Similarly, 1, 2 is here, 1, 2 is here, but 1, 2 is not here. You cannot take 1, 2 is not. 2, 4. 2, 4 is there. 2, 4 is not in B. 2, 4 is, so that is also not taken. Similarly, 3, 4. 3, 4 is there. 3, 4 is not here. So that is also not there. This set is also not present there. Now, any set, this may be in A and P and PB, but that is not in C. So we cannot take that. So for third part, you can take X as null set and singleton set 2 because these are the two subsets which is presenting the power set of A, power set of B and power set of C. So X is taken as that. Now, so that another question, question number 4. Another question. so that number of element in power set of 5, that is equal to 4. Now when you want to define 5 is a set, you want to write the power set of this set. It has no element. Power set of 5. It consists of one element, that is 5. Because 5 is a subset of every set. So 5 is a subset of 5 also. So in this case there is one element. Again, if you want to find out power set of 5, then what you can write? That is equal to 5 is a subset of every set. And then again 5. Now in this you got two elements. Again then you want to find out power set of 5. Then what happens? That is equal to 5 and one more 5 . So in this way you can see that there are 4 elements. 1, 2, 3, 4. There are 4 sets which are the subset of this. So therefore number of element in power set of 5, this is equal to 4. In this way you can prove this result. Now I am doing some questions. Now I am doing some questions based on subsets and other definitions which is asked in competitive exam. Now you see that. Question 5. Which of the following is a singleton set? Is a singleton set. A. This is defined as all x such that mod x equal to 5, x belongs to n. B. All x such that mod x is equal to 6, x belongs to z. C. This is defined as all x such that x square plus 2x plus 1 equal to 0, x belongs to n. D. All x such that x square is equal to 7, x belongs to n. You have to find out a singleton set out of this. Which one is a singleton set? As I told you, in order to find the singleton set, if the set is given in set builder form, you have to write them in roster form. Means the element of that set. So this set consists of one element, that is 5, because when mod x is 5, then value of x is minus 5.5. But here again one condition, x is a natural number. So this set contains one element, that is 5. Now come to second part. Mod x is equal to 6, but we have given that x belongs to that z. Z is a set of integer, negative and positive both. So value of x from this equation is minus 6 and 6. It has two elements, minus 6 and 6. If mod x is 6, then value of x is minus 6 and 6. And x belongs to set of integer. So therefore both are the element of this set. Now we reach to third part.